today we're walking through Leetcode 111, minimum depth of binary tree. The problem is simple. Given the root of a binary tree, return its minimum depth. In other words, we need to calculate the number of nodes along the sorted path from the root down to the nearest leaf node. We will use the recursive approach, which is elegant, short, and often asked in interviews. When we recursively go down the tree from the given root node, we might be encounter 4 cases. Case 1. If the node is none, we return 0. That makes sense. No node, no depth. Case 2. If the node is a leaf, meaning it has no left child and no right child, then return 1, the node itself. Case 3. What if the node only has one child? Let's say it has no left child. Then we need to return 1 to count itself plus the min depth of its right subtree. Same logic applies if it has no right child. Return 1 to count itself plus the min depth of its left subtree. Let's say node 3 don't have left child. Then at node 3 the function will return 1 plus the min depth of node 20, the right subtree. Very important that we don't take the min of the left and the right. If left is missing, it's not a valid path. Case 4. Finally, if the node has both left and right child, we return 1 for the node itself plus the smaller min depth of the 2 subtrees. So what's happening overall? As we go down the tree, at each node, 4 cases can happen. If the node is none, we return 0. If the node is a leaf, we return 1. If the node has only one child, return 1 for the node itself, plus the min depth of its only subtree. If the node has both children, we return 1 for the node itself, plus the shorter min depth of its 2 subtrees. Let's take a closer look at the example on the left. First, we call the min depth function passing the given root node 3, f3. Let's move it out the way. f3 will return 1 and the smaller of its sub-3 min depth, f9 and f20. f9, the min depth at node 9, return 1 for the node 9 itself because it's a leaf. f of 20, the depth at node 20, return 1 for itself plus the min depth of its left subtree f15 and its right subtree f7. Min depth at node 15, f15, return 1 for node 15 itself. Similarly, the min depth at node 7, f7, return 1 for node 7 itself. Let's bring everything down to one row. The final outcome is 2. As you can see, there are 2 nodes on the sorted path from the root down to the nearest leaf node. Alright, it's time to smash the submit button. Boom! Accepted. That's the recursive solution to the minimum depth problem. It's handled missing children correctly. If you found this helpful, check out the other binary tree videos on the channel. We covered traversal techniques, tree comparisons, and more. I'm Alan and this was Leetcode.